getting into the building tonight. But thank you for hanging around. Thanks for coming. This is our second community forum this week. I am Kirby Kester, President-elect of the Hawaii Crop Improvement Association, and we're here tonight to have a friendly and respectful talk story about farming, food, and our future. We want to discuss the real challenges facing farmers on Kauai, how food is grown and raised safely and responsibly, and what tools are used to preserve and protect our lands and resources for future generations. Our panelists of respected farmers and scientists from Hawaii and the mainland will be here to will be able to answer your questions about agriculture, GMOs, pesticide use, and farming on Kauai. But before I begin, I want to invite up Pastor Donnie Kimi to start off our forum with a fluid.
Aloha, everybody. Good evening. One more time. We can do better than that. Aloha, everybody. Aloha. If you're able to stand, would you please stand as we bow our heads in prayer? Heavenly Father, most gracious Father, Lord, we just, first of all, thank you for allowing that storm to pass our island yesterday, Lord. And Father, very minimal damage, Lord. And Father, we thank you for that. Lord, we ask that your presence would be here this evening, Lord. And Father, you have designed us to see things differently, Lord. We're not designed to see eye to eye, but we are designed to see heart to heart, Lord. And we are designed to see Kauaian to Kauaian. So Father, we ask that your presence would be here, Lord. And Father, when we're finished with this, Lord, that you would take us all home safely this evening in this weather, Lord. We ask this in the mighty name of our Lord and Savior, Jesus. Amen. I'd like to bring up Mayor Bernard Carvalho as he comes and sings the Hawaiian doxology with me. Would you? Okay. He's got the voice, that's why. We got the voice. Okay. Thank you, ABC.
All right, thank you, Mr. Mayor and Pastor Donnie. I also want to acknowledge Councilmember Nadine Nakamura is here today. Thank you for coming in. And at this time, I would like to introduce our two lovely moderators for the evening, Lori Ho and Susan Tai Kaneko. So, Lori Ho is a graduate of Kamehameha Schools and obtained a degree from the University of Hawaii at Manoa in agricultural technology. She's worked for the United States Department of Agriculture with the Natural Resources Conservation Service for 32 years, with 25 years of that here on Kauai. She believes in building effective partnerships with government agencies, community groups, and individuals, and having good working relationships with everyone. And Susan Tai Kaneko has over 15 years experience in business and economic development. She was most recently the director for the Kauai Economic Development Plan at the Kauai Economic Development Board, overseeing initiatives in renewable energy, food, and agriculture. And strategic planning. She also manages the implementation of the county's 10-year Comprehensive Economic Development Strategic Plan, better known as SEDS. And prior to that, she was director of the SBDC, working with small businesses and our local community. They will facilitate the discussion tonight with the following panelists. Jerry Ornelas, President of the Kauai County Farm Bureau. Dr. Dennis Gonzalez, former director of the Pacific Basin Agricultural Research Center. Dr. Kevin Folta, University of Florida Horticultural Services. Dr. Stephen Savage from Savage and Associates, and myself, Kirby Kester. And with that, I'll now turn over the mic to Lori and Susan.
Mahalo, Kirby. So aloha, mahalo officially. Thank you for being here this evening. In order to create a safe environment for everybody here to be able to share their presentations, but also be able to ask their questions, what we'd like to do is go through a couple of house rules that we have, just to set some ground rules for discussion and presentation. But as your moderators, I just wanted to explain what Lori and I will be doing is to try to make the event flow as smoothly as possible. We'll introduce the speakers, but more importantly, we'll manage the question and answer later. We had a pretty good round of questions yesterday in Waimea. Our speakers were more than happy to try to field as many questions as they could, but what we realized was a lot of people have a lot of questions, and so what we want to do is to allow everybody to have a chance to at least ask one question, and after those folks are done, we can go back to folks who have a second question. So if you don't mind respecting that, that'd be wonderful. Vanna, over here, by our house rules, what we really like to do is ask you to participate actively and also listen actively. And also please, no side conversations to distract others from the presentation and the discussion. If you'd like to have side conversation, please feel free. If it's not pouring rain outside, if you want to step outside, and once you're done, come right back in. Please respect each other, their opinions, their comments, also the topics and the time frames. And as Pastor Donnie said, and I'm sure you've heard it everywhere, aloha is just not a word. It's just not a word that we throw around easily. And so please extend aloha to each other, to the panelists, to the coordinators, and definitely everybody sitting here in the audience deserves aloha. Please be open-minded to constructive feedback, giving it and receiving it. And also, communicate your questions clearly and concisely because we do want to be able to get to as many people as we can. It'll just enable people to be heard, everybody to be heard. Seek understanding of differing viewpoints. We know this is a hot topic in the agriculture sector, but for us as your moderators, but also you'll see from the presenters here at this stage, what we really want to do is provide useful information, but also hear your questions reflecting your concerns. You can agree to disagree, and that would be wonderful, just really showing aloha and respect to each other, but really please agree to disagree. And then a couple housekeeping, I'll go to that one last. A couple housekeeping rules, if you don't mind, just silence or turn off your cell phones. And the restrooms are right outside this door here. Take a right, and it's just the first nook off to your right there. And then, that's right, in terms of question and answer, as I mentioned, we're gonna try to get to as many people as possible. And if we could ask you to limit it to one question at a time, we'll get back to you if time allows for second questions. But then also, when you ask your question, if you know who you want to direct it to, because you'll have a sense of, after all the presenters are done, you'll have a sense of who to direct your questions to. If not, we'll try to assist with that. But then also, I believe on the handout information is emails. It contains the emails of our speakers because they welcome follow-up questions. I think they'll be here for a few minutes after the event, as much as time allows and the lights are still on in the cafeteria, but they also do welcome questions, so please feel free to email them. And then with that, I think I will turn it over to Lori to start introducing our presenters.
Okay, does this mic work? Let's try it. Hello? Turn it on. Okay, one moment. Hello? It works. Thank you, Susan. So, our first presenter is Kirby Kester. You met him earlier. Kirby is the current president-elect, feedback, of the Hawaii Crop Improvement Association and is employed by BASF Plant Science in Kapa'a as an applied genetics manager. With 18 years, am I standing in the wrong place? Is that why it's feeding back or something? Oh, okay. Louder. Ooh, I can do loud. 18 years of broad experience in the seed industry on Kauai. He now manages seed production for the development of new traits in corn, rice, soybeans, sunflower, and canola crops. Kirby?
Thank you, Lori. I just want to thank everybody again for coming out tonight. I know it's probably one of the hottest and muggiest nights of the year, so it's kind of uncomfortable, so thanks for bearing with us. As previously stated, I've been working in the seed industry on Kauai for the past 18 years in various roles entailing field supervision, production, administration, and now trait development and regulatory compliance for BSF. I've been a member of the Hawaii Crop Improvement Association since 1995 and am the current president-elect and board member. HCIA is the trade association for all the seed companies in Hawaii. And the seed industry on Kauai is made up of 4 companies: Dow AgroSciences, DuPont Pioneer, Syngenta, and BSF. Collectively, we farm about 13,000 acres of land on Kauai, which is spread out basically from Polihale to Honolulu. This number represents less than about 20% of the tillable, of the 80,000 total tillable acres of farmland on Kauai. We employ around 600 employees annually, depending on the time of the year. Most of them reside on the west side of Kauai. We annually contribute roughly $80 million to the Kauai economy. We do not have any income via sales on Kauai, nor are we government subsidized. So this money is pretty much a direct injection into the economy in the form of salaries, contracts with local businesses, construction work, and other money spent in our local communities. Nearly 100 local businesses or associations work with this industry. So why is the seed industry even on Kauai? The simple reason is the weather and the ability to carry out our plant breeding and seed production work year-round. Most people don't realize that nearly all the plants have the ability to be improved via plant breeding techniques. There's tremendous efforts around the world on all the major food crops to enhance yield, quality, and resistance to various pests or diseases via plant breeding. So our industry started on Kauai in the late 1960s, mainly just to increase parent lines of corn during the winter months for commercial production and sales in the U.S. Corn Belt. In plant breeding, since there are typically visual plant selections conducted on each cycle, looking for the best characteristics of that plant, it can take numerous generations, up to 15, to create a new product. So if these activities were only conducted in the Corn Belt where the product was sold, it would take 15 years. But since Kauai's climate is conducive year-round, we can complete 3 and sometimes 4 cycles per year, which in turn really helps us reduce the product development timeline. So our fundamental business here is to produce seeds which are sold to farmers in the US and around the world. They may be created with both traditional breeding techniques as well as the latest biotechnologies like genetic engineering. We develop plants with improved characteristics based on the demand of our customers, who are farmers that want crops with higher yields, better disease and insect resistance, with better nitrogen use efficiency and drought tolerance. So the ultimate goal of our breeding efforts here are to create plants that provide the highest yield, nutritional value, or industrial use with the smallest environmental footprint possible. That's why biotechnology is very important as one of the tools in providing food for the future. So, thank you.
Mahalo, Kirby. Just as a reminder for folks who came in late, there's some snacks and beverages back there, so please stay hydrated. Please help yourselves. Our next presenter will be Dr. Dennis Gonzalez. Dr. Gonzalez, who was born and raised on a sugar plantation in Kohala, recently retired as the director of the USDA Pacific Basin Agricultural Research Center in Hilo. It's a post that he held for 10 years. He led the team that developed the virus-resistant transgenic rainbow papaya that saved the papaya industry in Hawaii in 1998. For this work, he and his team received the Alexander von Humboldt Award in 2002 for the most significant accomplishment in American agriculture in the past 5 years. I'd like to introduce Dr. Gonzalez.
Thanks very much. I am very happy to be here. And actually, I essentially started my scientific career here in Kauai. I had graduated from the University of Hawaii in 1965. And I come to work at the University of Hawaii Experiment Station behind Sleeping Giant. And we actually lived in a small house behind Sleeping Giant, and the house was owned by this rancher called Aguiar, and it must have been 400 square feet. It was during the work that I did at the station where one day my supervisor said, you know, investigate this papaya disease. And I was just a technician, and I started looking at the disease, and that made me know what I wanted to do. After doing that, I figured, you know, I really like research. So I started a research career after that, got my master's. Got my master's and a bachelor's at the University of Hawaii, and then my PhD at the University of California, Davis. I spent 6 years at the University of Florida working on citrus. Then the next 25 years at Cornell University, where we did the papaya work. Then 10 years ago, I came back to where I was, the island I was born on, and I just retired at the end of 2012. Well, what I hope some of you might move forward. I don't know if you can see this thing back here, but what I'd like to do today is talk to you about the papaya story. And essentially, it's a story about genetic engineering done through the public sector. All of this stuff was done by myself at Cornell University, a couple of professors at the University of Hawaii, and also a person at USDA. So essentially, it's a work that we did, and actually, this story started many, many years ago. I just come back from Cornell in 1978, and I talked with the dean, and he said, you know, the papaya ring spot virus is in Hilo, and 95% of Hawaii's papaya is being grown in Puna. What would happen if the virus ever gets to Puna, only 19 miles away? I said, I think it's going to be devastating. So he said, can you try to develop a control method? And that's how we started, way back in 1978. But in the mid-1980s, we started to develop a genetically engineered papaya that we hope will be resistant. And in this here, I'll talk about probably 7 minutes. We'll briefly over what we did and just highlighting the certain things we did. And if after the question time you want to ask us questions, I'd be more than happy to answer. You got to tell me how this thing.
Can you forward it?
Okay, let's go. I'll just say next one. Okay, so you can see it's very dark here, but like all plants, a lot of plants have virus diseases. And this is here is the papaya ring spot virus. And the virus was in Hawaii since 1945. It essentially devastated the industry in Oahu, and the industry moved to Puna, where you had 100 inches of rain a year, a lot of sunshine, volcanic soil, just right for growing the Kapa'a variety. Next slide. And so, as I mentioned, I started to work way back in 1978, mainly because of the potential problem that the virus might get to Puna. Next slide. So, what did we do? In 1985, a concept was developed. Essentially, it said that if you put a small part of a pathogen, like a virus, a small part of it, if somehow you could get it into the chromosome of the plant, you would essentially vaccinate that plant so that it would resist the virus. And this was a new concept. It was called a pathogen-derived resistance. So utilizing molecular biology techniques, we got the cold protein gene of the papaya ring spot virus, and then through various means got it into the chromosome of the papaya. Now we started the work in 1984. Next slide. But by 1991, we had some genetically engineered plants, and we inoculated them in a greenhouse. And I think even from the back there, you can see the plant on the left is big, the plant on the right is small, and essentially, we had inoculated these plants with the virus when they were very small, and the one on your right stayed stunted because that was not genetically engineered. The one on the left kept on growing. And we said, oh my gosh, we actually had, looks like developed a papaya that was resistant to the papaya ring spot virus. And this essentially is how, in a nutshell, how we did it. Again, just taking a small piece of the viral gene, put it into the chromosome of the plant, and essentially vaccinating the plant. Next slide. So, in May 1992, I was flying back from Guam, and we landed in Honolulu, and was met at the airport, and they said, you gotta go to Puna. So we went to Puna, and essentially they said, the virus was in Puna. So what we thought what might happen in 1978, in May 1992, the long-awaited invasion of the virus into Puna was detected. Next slide. So, this is a dark slide, but in Puna, 1992, it was a way of life. People were growing papaya, beautiful, really nice papaya, the Kapa'a variety. And the virus came in May 1992, and within 2 years, next slide, essentially, there was devastation. The virus was spread by aphids, by insects, very rapidly, no resistance, the industry was going down. In 1992, Puna was exporting or producing 53 million pounds of papaya. By 1998, they're down to 26 million pounds of papaya, mainly because of the virus. Next slide. So, having gotten this genetically engineered papaya in 1991, Richard Manzar, the horticulturist, started working towards developing a commercial variety. And that's one of the advantages of this technique. We actually had transformed the sunrise papaya, the sunset papaya, which is commercial. So that itself was commercial, but we wanted also a yellow flesh papaya. Now, remember, this gene is in the chromosome, so you can transfer it from generation to generation. So essentially, by 1995, we had the sun-up transgenic papaya and the rainbow papaya. Now, in order to see if this thing would work under field conditions, we did a field test starting in October 1995, and by 1996, us scientists were working to try to get the papaya deregulated. Next slide. So you can see here in the field trial in 1996, on the left, you can see the non-genetically engineered papaya were naturally infected by the virus, yellow, stunted. On the right, you can see the rainbow papaya growing very strong, very tall, very resistant. Next slide. And if you look at an aerial view, it's very hard to see here, but basically the solid block in the middle is a rainbow papaya, the very whitish gray where the plants are dying essentially is the non-transgenic papaya. So under field conditions, it was working. And if you look at the fruit on the right, you see the fruit actually had ring spots. These were the non-genetically engineered papaya. And that's why they call it papaya ring spot virus. Whereas the papaya on the left was a rainbow papaya that showed resistance. So 1997, we looked like we have something. So how can we get it to the growers? Next slide. So actually, again, I had never done this before. But in order to get it to the growers, we felt that we are scientists ourselves, because all of this was supported by public sector work, no funding from private companies. So we essentially worked with APHIS, EPA, FDA, and by 1998 we had transgenic papaya deregulated. In April 1998, the Papaya Administrative Committee or Grower Committee actually got licenses from different companies, such as actually Monsanto, Cambria, to practice this commercialization. And in May 1st, 1998, about 6 years after the virus came into Puna, the seeds of the transgenic papaya were distributed free to the growers based on a lottery system. Depending how much they were infected, they could get seeds. So, later developments in 2003, the papaya was deregulated in Canada, and recently in December 2011, the papaya has been deregulated in Japan. Next slide. And the growers grew the transgenic and right next to a non-transgenic field, and it grew beautiful. Next slide. And if you go to Puna today, more or less you'll see just healthy papaya, mainly because nearly all of the plants are genetically engineered to be resistant to the virus. So since 1998, it was commercialized, so it's been commercialized for 15 years. Next slide. Now, the virus is still around. That's what is very important to know. Some people try to grow Kapoho, non-transgenic papaya in Puna, and you see in the back there's a field of rainbow papaya, healthy. The field, foreground, was all infected by the virus. So the virus is still around, and that's why essentially 85% of Hawaii's papaya is genetically engineered. Next slide. Now, why did we do the work? Essentially, it was the scientists were trying to do the work to address the problem that was affecting the farmers. That's why we did the work. And, also, as a result of the work, the papaya is readily available now in the market. You can go to the farmer's market and get 4 papaya for $1. I can tell you, in the mid-1990s, you could almost not find any healthy papaya. So, next slide. And so, more or less in my short talk, I just wanted to stress that we were addressing a serious problem. It was done by the public sector, scientists, and we've done all the safety tests. I can show you whatever data you want to have. We have them. It's all public records. So this is the papaya ring spot virus story. Thank you.
Sorry, we had a technical difficulty there. What was the last slide, Dr. Benson? That was the last slide. Okay, very good. Thank you very much, Dennis. Now, our next presenter, there you are, is Dr. Kevin Fulton. He is Associate Professor and current Chairman of the Horticultural Sciences Department at the University of Florida in Gainesville. He has been recognized as an award-winning scientist studying the genomics of horticultural crops and the molecular biology of signal transduction in plants. He has authored over 50 scholarly reviews, research articles, and book chapters, and served as editor to 2 seminal texts in fruit genomics. Kevin, you ready?
Yeah, I'm awesome. Thank you.
There you go. Lay adjustment.
I need a lay adjustment. All right.
The-
Tie goes in back.
yeah, no.
No. Okay, well that's good. Wouldn't want to come out here looking crooked. So thank you very much. I really like this one much better than last night where we were up on a stage with very bright lights and felt like a turkey sandwich all night. This is really nice. Wow, that was tough. Well, this is, so I wanted to give you a little bit about my motivations and why I'm here, and maybe a little bit of understanding about where I come from in this. I'm very active in trying to, as a university scientist, very active in trying to fulfill one of the critical parts of the land-grant mission. As chairman of a horticultural sciences department that covers everything about horticultural sciences, we have 56 faculty serving many different horticultural industries in the state. I'm very interested in one of the legs of our mission, which is extension, which is bringing the science out to the public. And I do this through a variety of mechanisms online, and was contacted by the group here to see if I could come out and discuss this with you. It's important because I'm a scientist. I'm a neutral party in that I play by the evidence. I read the journals, I understand the work, I talk to the scientists, and I'm not sponsored by any corporations. We have a tiny research grant with one company to study flavors, and nothing to do with GM. But none of the big players fund any of my work. I'm all federally funded and funded by the strawberry industry, which doesn't have any anything to do with GM. So I'm here as an independent voice to give you some ideas about what a scientist sees. And in an emotionally supercharged issue like this, where there's multiple sides that really have a voice, what I want to do is just kind of let you know where the science stands, particularly on the issue of biotechnology. This is an introduction. In a couple minutes, I can't give you everything. And what I'd like to do is just give you an idea about some of the main points. I want to try to anticipate and read your minds and give you some questions that I've prepared ahead of time to answer. Answer during the Q&A, and most of all, maybe after the session. Come talk to me. Get my business card. Send me an email. We can Skype. I would love to be able to handle your questions and concerns, because personally, I'm a firm believer in the technology. I think it has a lot more benefit than risk, and certainly is something that will be part of our future. So the first slide that I have up here is, and I guess I kind of already answered the question. Go ahead and next slide, please. Thank you. How much did Big Ag pay you to do this? And there's a little bit problem with the slide here. And I already mentioned the answer is zero. Okay, I'm here. I'm actually here as a volunteer. I'm not getting paid an honorarium. I'm not getting paid anything to do this. So I've been here for whatever 7 days, talking to people strictly because I want to share the science, and that's. My public funding is completely public record. You can check that. The next question that I had on the board coming up was, is the technology safe? Tell us about biotechnology and this idea of inserting a gene from one plant to another. Actually, the first question was, why do we need biotechnology? Why do we need GMOs? Why are they of use for us in horticulture? And yeah, you got the next one? It's frozen up? That's all right, I have it memorized, we're good. The next question is, why do we need this? And why is it even something that we consider? And one of our first ways of improving crops is through traditional breeding. And all of the work in my department is done through traditional breeding. We're crossing an elite line with another elite line, and then using selection to identify plants which contain superior traits which are good for consumers. And the big problem is, most of the traits that we're selecting for in the industry, for say strawberries or blueberries, are traits that have to do with shipping, right? I mean, who cares if it tastes great and it's a wonderful berry, but it gets to the store and it's mush or it rots right away in your fridge. We need stuff that's really shippable, and we do that at the expense of things like flavors. So when we're, as traditional breeders, it would be really nice if there was a way to move genes faster. Rather than having to cross two plants and take years and years and years to identify a good plant through traditional breeding, moving genes that we don't know what they do in ways we can't predict by. What if we could take the one gene that we know exactly what it does and move it to this other plant? And that's exactly the idea, is to accelerate the breeding process, to make plants contain genes and traits that we didn't have in there previously. And this is the central idea. This is why we need it, and this is why I believe it'll be part of our future. Isn't manipulating plants' genetics unnatural? And that really ties in with the last part. As humans, we've been manipulating plant genomes, and genes in plants. So a genome being all the genes together in a plant. We've been manipulating genes and genetically modifying plants for about 20,000 years. Since the first humans looked at a patch of early corn and said, this one is giving us more per plant than this one, so we're going to take the seeds from that one for next year. That was the first time there was selection, and we started the process of breeding. We started to select the superior genetics, and then throughout the next 20,000 years made tremendous advantages from a little stick with 13 kernels called teosinte to the large ears of corn we see today. Next one. Well, the next slide is kind of one to make you laugh, so you can go ahead and do that now. It was reminding us that what is natural, and really everything that we eat, everything we consume, isn't technically natural. Okay? All of the plants that we consume are manipulated by man in one level or another. And what would be really surprising is you find out that virtually every crop we eat, very few of them come from North America. Most of the things that we consume are coming from South America, somewhere in Asia, or Southeast Asia, sometimes from Mexico, corn, squash, and tomatoes, or corn, squash, and beans. So most of the things are aliens in North American soil. The next slide, please. And this one is just a slide to remind us where we were and where we are. And really, we've gone from plants which are basically almost unusable. Plant products like tiny, tiny little bananas full of seeds, tomatoes which taste horrible and are vines on the ground. In this case, teosinte, the 13 little corn kernels on a stick that were possible to grind, that now are these very beautiful ears of corn. All of this was done by genetic modification by humans in ways that we didn't know what we were doing. Now, we have a very sound technology where we have great precision and understanding how we can move a single gene. Next slide, please. And I already covered this with why do we need it. The next slide, please. What about rubber stamp approval? And this is a question that always comes up. If you talk to people who are critical of the technology, they frequently will tell us that this is a rubber stamp process. Monsanto goes in and says, we want to release this. Government officials who have been well greased with lots of dollars rubber stamp that document, and now that new plant can go everywhere they want it to go. And this is patented, folks. For us as scientists, I shouldn't say us because I don't release plants. I don't release genetically modified germplasm because as a public institution, we can't afford it. And we have plants, freezers, refrigerators full of seeds and plants that could have tremendous benefit to the industry, but that's where they will die for the time being. My lab has a strawberry that has a small protein from strawberry that's expressed in a high level in the roots that in the greenhouse, nematodes won't touch it. But we can't test it. We can't grow it in the field. We can't do anything with it. So strawberry, one of the most fungicide intensive crops, and nematode treated crops with fumigants, very powerful fumigants, we can't use that. And so now we continue to insult the environment with chemicals and compounds that could be completely relieved by use of our plant. So it's not a rubber stamp. The average plant takes about 5 to 10 years, and I think it's somewhere between $5 and $20 million to deregulate. Dr. Gonsalves can tell us more about that because he's gone through the process. But it's an extremely expensive process and extremely time-consuming. It has to move through the FDA, has to move through the USDA, has to move through the EPA. All of these different agencies look at this one at a time, stringent tests, and substantial cost. So releasing a line is oftentimes very difficult. Next slide, please. How do we know they're safe? And how do we know they're safe really starts with kind of safe is a funny word for scientists. I don't like to say that anything is safe because we can't possibly test the constellation of all possibilities. What I can tell you about transgenic food is that there's no evidence of harm. Despite what some will say, if you look at very carefully at how these proteins work, we understand, say, glyphosate-resistant corn or BT corn or cotton that produce a peptide, which give it immunity against certain types of earworms. We know how these proteins work with tremendous accuracy. We know how they behave in vitro. We know what proteins they bind with. We can test the plants that contain them and ask what else is happening in terms of collateral gene expression or where these genes are inserted. We can do this with tremendous resolution these days. And so we know that there's nothing unpredictable. This is a frequent argument that we can easily dismiss these days. We also know that these have been extensively tested, not only by the companies that make them, which most people say, who cares what they think, but also with independent science. If you look on biofortified.org in the genera database, you'll find over 600 independent studies, many of which cover these types of compounds and these types of plants. The other way that we know they're safe is by looking at epidemiological studies over the last 15 years since these have been released. And you don't find one single, well, on the epidemiological level, you don't see any major trends which are consistent with the production of these plants. You also don't find any acute instances where one person has been harmed by an allergen or some sort of reaction. You just don't find those documented cases. Next slide, please. So what are they doing on Kauai? And this is something earlier that Kirby discussed, but I'll touch on again, is that this is a wonderful place to get multiple generations of breeding done per year. If you're going to try to improve plants, try to improve, say, inbred lines or other types of corn plants or any kinds of bred crops, you have to get in as many growing seasons as you can, as fast as you can. In Florida, we do this also. We can get 3 seasons in Florida with tremendous disease pressure, which you probably get here too. So if you can make it happen on Kauai or Florida and do it very rapidly, it's a tremendous benefit towards improved lines for farmers. And so this is the main reason why these crops are here, is that the new selected traits, which are not GE, are moving in the background of something that is. And that way you can confer the traits that have been added by biotech along with the traits that are naturally there. And together these give us an improved product. Next slide, please. So what about health problems? And many of you are familiar with the reports that came out last year that said that these give rats cancer flat out, no doubt about it. And this has been something that activists have grabbed onto, and this is something that, to me, not only, it really bothers me as a scientist, because I looked at this paper and couldn't believe what I was reading. And the scientific community is across the board come out highly critical of this work. Independent scientists worldwide, not just in the US, and a gigantic rebuttal of this work came out just recently in Spanish group. The bottom line was, and many of you have seen this image, and these images are being used in many cases as propaganda against biotech. And then maybe show the next slide. You see oh yeah, so this is Babes Against Biotech. They have it on there. It says, rats fed GMO corn develop massive tumors. This is what it's going to do to your family. Okay, those 3 lumpy rats. And then the bottom is from Jeffrey Smith's publication saying, again, showing the lumpy rats. Next slide, please. Maybe push the button, see if it goes. Okay, so this one says cancer growl over GM foods. As it says, this did this to rats, again showing this, and said damage and early death in humans. That was never assessed. There's no link to damage and early death in humans, but they made that connection. The next slide, please. Again, new proof, the word proof, GMOs cause tumors, damage, and premature death. The paper didn't show any of that. Yet, this report is highly touted by those who are against the technology, and they use this for one reason, is to generate fear. And this is something that is really a very potent part of the agenda. If you look at the next slide, this is directly from the paper, and there's 3 different rats there getting either GMO corn plus a dose of the herbicide Roundup, and then another one with just Roundup. What's missing from that figure? They show 3 rats that received treatments and they say caused the cancer. They leave out the rat that just got regular rat food. No GMO, no Roundup. And if you look at table 2, he got it too. So if you go to the next slide, also develops tumors. This is a kind of rat that develops tumors that far out. So this was an experiment that was predestined to show these results. As a scientist, that really bothers me. And if you don't believe this, a few heads out there go, no. If the control gets tumors, why would you leave it out of that image? Unless the intent of that image was to develop fear. And that really, really bothers me. We can talk more about that later on. I'll be happy to address any of your questions. Okay, next slide, please. So conclusion was that the technology has been around for a long time now. We know quite a bit about it. We know the way it works. We understand the genes that are inserted and what they do. We know this with tremendous detail. It's been in the public for 16 years without a single incident that could be linked to it directly. We know the technology has strengths and limitations. We know that looking forward, it will be part of whatever systems that we're using for growing plants. Personally, I've always felt that the future belongs to low input agriculture. Whatever we can do to grow more with less input. And so you'll see the best of organic and sustainable techniques married to transgenic crops, which are designed to thrive in those environments. This is what I think we'll be seeing. I have a really good feeling about that. So I guess I'll conclude there. I'm really excited to take your questions. Please, if you have a question tonight, stick around afterwards. I really want to talk to you about it. I'll be happy to do that. So thank you very much.
Hello, Dr. Fulton. If I could, I'd like to take a couple seconds to recognize a few more of our public officials who walked in. I think I saw Councilmember Joanny Humura right over there. Thank you for joining us. And former State Representative Roland Sagum. Thank you, Roland, for joining us. And I thought I saw George Costa, our Director of our Office of Economic Development. Hi, George. Thank you for joining us. So up next, we have another renowned agriculture scientist. He'll shed some light on the pesticide issue. Dr. Steve Savage has more than 30 years of experience in agricultural technology, having worked in academics at Colorado State University, at a global research company at DuPont, at a biotechnology startup at Mycogen, and for the last 16 years as a consultant. In recent years, he's worked extensively on the topic of sustainability, and I'd like to welcome up Dr. Stephen Savage.
Thank you very much. I do enjoy being here, and I'm always glad to come to Hawaii. As I said at the last meeting, just before the first time I came to Hawaii, we got a call. They said, "Don't come, the hurricane's coming," and it was Iniki. And so I'm glad I didn't have that effect this round. So, yeah, I'm going to talk today about pesticides, and this is obviously not the easy assignment for anybody. Pesticides aren't something that most people know really all that much about, but they sound pretty scary, especially when you hear a word like restricted use pesticide. And I think one thing that helps a lot to put the whole discussion into a little bit of perspective is something that they never teach us in school, which is the difference between hazard and risk. So if you think about it, electricity is an extremely hazardous thing. But we have a lot of mechanisms that may give us low risk from it, basically by doing things to make it pretty hard for us to stick our fingers in and get a good dose of it, okay? We've actually come a long way in that regard. When I first moved to my current house, my 90-year-old neighbor, a dear guy, would always ask if I could help him put up his Christmas lights, which I think he probably bought in about 1945. And we'd be putting up these lights, and I mean, even something like Christmas lights would come a long ways. So I think the same thing is true in pesticides, but it's not something that we know about. But I want to just put something in perspective. I was hearing some things on the radio today, and people talking about their fears about pesticides and what they were sure was happening for pesticides. And I thought, these people are talking as if nothing ever changed after Silent Spring was published 51 years ago. Now, I didn't read it at the time, I was only 7, but I certainly was raised in a generation where we were completely aware of the dangers of things like pesticides and certain other chemicals and things, you know. But in the 1960s, nobody knew about that. It was a whole different world. And unlike the biotech industry that doesn't have bad old days, there were bad old days. There were serious bad old days when people thought that something like lead arsenate was a pretty good option, okay? It's hard to imagine that the mindset was ever there, but it was. But that has changed a lot, and to sort of act as if it didn't is to act as if, you know, Silent Spring had no legacy, or that the environmental movement that it started didn't accomplish anything, and it did. And one of the things that happened is that we have a very elaborate regulatory system, which has only been getting more and more refined over time, which does this work of saying, how do you take something that is a hazard, and how do you mitigate the hazard so that it's a low risk? We've also invested a tremendous amount in research to find newer, better options, which are actually lower hazard to begin with. So for instance, the way that we power our laptop here is not the kind of voltage that is nearly as dangerous as what your camera is plugged into. So similar thing happening with pesticides. A lot of pesticides are really not that hazardous. In fact, some of them have almost no hazard at all. Gets back to this list of the Kauai restricted use pesticides used on the seed farms. So if we could go to the next. And these are part of the public record, and that's what's been discussed extensively in recent months here. And I'm not going to give you my opinions about it. My opinions don't matter. All I'm going to do is talk about what information is available today, transparent public databases that allow you to say, instead of just, oh, it's pesticides, to say, well, what pesticides, what are the issues, and what are the things that are done to try to keep those safe. And those are some of the sources, and rather than read those off, I'll kind of list them when we get to the points. And by the way, I'm happy to help anybody find these and to learn how to use these databases. Some of them are very easy, and some of them are not so easy. Okay? Okay. When you take that list and look things up, and the list just says, what's the product name? So you have to say, well, what is the amount of active ingredient per gallon or per pound or something like that? Convert it into that, turn that into pounds, and I come up with what's considered the agricultural use to be something on the order of about 29,000 pounds of pesticide per year. Now that sounds like a lot, okay, 29,000 pounds, because we don't normally do anything that we personally handle 20,000 pounds of anything. But actually, it's not quite as much as it seems like. First of all, about 14% of that is used for weed control in the coffee plantation. And what they're using there is actually a pretty good choice because it's a way that they can control weeds without having to disturb the soil so that it blows away and all of that sort of thing. And so it's not such a scary thing. 14% of that total agricultural use goes for the coffee. Okay? And then another 9% of it isn't actually really agricultural use in the way that you think about it. I'm sure you've seen many times when somebody's house is being tented for termites. Well, this is the sulfurofluoride is what's used for doing that. The same thing is used in grain bins to get rid of rodents and insects that would otherwise be chewing on the grain while it's being stored there. So it's sort of the same tent the thing kind of use, okay? So then that leaves you about 22,000, 23,000 pounds a year. And that's being used on roughly 12,000 acres of corn. So that's 1.9 pounds on an acre. That's not a huge amount, okay? If you do the math on what an acre is, that means you're at 0.00004 pounds per square foot spread over an entire year, okay? Now, just to put that in perspective, if I were to look at, say, organic grapes being grown in Marin County, California, I'm from California, they'd be using things that are fairly high use rates like sulfur dust and copper sulfate. They could easily be spraying 100 or 150 pounds of those per year, per acre. That's kind of an extreme case. So let's compare this 1.9 pounds to something more appropriate, which would be other corn. So really corn, it's all about the Midwest, right? So let's go to that. Oh, sorry. The other thing that you can easily look up online is, well, how toxic are these things and why are they on the restricted use list? I think when most people hear restricted use, they think it's because they're toxic. Some things are on the list because of that, which means, and besides, what the restricted use means is the restriction is who can use it. There are various restrictions on virtually all pesticides, but this says who can use it. And the who can use it are people who have the most training. All the people who do commercial pesticide applications in the modern era are trained, but there's different degrees, and you have to have the highest degree to use these materials. And the reason you need to do that is because your responsibility is to do the things that mitigate our hazard to be a lower risk, and you need the training. So you'd think, well, are these mostly toxic things? No, they're not mostly toxic things. The 98% of what's used in this list on an average year is actually less toxic, gram per gram, than the caffeine in your morning cup of coffee. Now, there's not a huge amount of caffeine in your coffee, but if you could sit down and drink 130 cups in the morning, you might actually be able to kill yourself with caffeine. I don't know how many Trentics is that, I'm not sure. Okay, and actually a fair number of the things that are being used and are on that list are actually extremely non-toxic. They're less toxic than citric acid in your orange juice or something like that. The reason that a lot of things are on this list is that you have to be particularly careful to not get them into water. So if there's, you don't want them to be near a wellhead, you don't want them to be near a stream, you don't want, there's a whole bunch of restrictions. And for some of these, you have to know, well, it depends on what is your soil type, and there's a whole list of things. So basically, the idea is that you have people trained to do what it takes, and there are all sorts of restrictions on the label. Okay, next. Now, I don't know if you can see that. All these bars are how many pounds per acre per year. This is from USDA survey data about use in corn in the Midwest. That's where we've got 80 million acres of corn. And so we're comparing it to where the real place that commercial corn is grown. And the red bar at the top is the average use rate in Kauai. And as you can see, it's lower actually than most of the others. And that's kind of remarkable in the sense that at least a lot of those places get a winter. And winter is really hard on pests. You don't get that in Kauai. And so pests don't have a time that they have to recover from. Next, so you might say, well, but corn is a weird thing to be growing in Kauai, and so is that why we have this particular list of chemicals? In California, we have something called mandatory use reporting. And so everything that's used in any commercial sense for agriculture or other uses has to be reported to the county. And this is all collected, and it's actually a very nice functional database where you can search things up. And so I just did that, and I asked the question, I'll take this list of things from Kauai, search it up and say, at least for 2011, what was it used in California and why? And what I found is in that year, we used 2.8 million pounds of these same chemicals. Obviously, California is a lot larger place, but we were using this on more than 150 different crops in 51 of our counties. So it's not like what's being used here on Kauai is some exotic thing that isn't being used anywhere else. And frankly, in California, we have pretty high standards. We have probably the most elaborate state-level EPA in addition to the federal EPA. And we also have plenty of sensitive habitats, and we have plenty of people living there as well. Next. So I think the summary is, first of all, pesticides have changed a lot. It may not fit your image from a long time ago, or what you've heard about. It is a very highly regulated activity. It's not like the environmental movement didn't accomplish anything. The EPA has been established. Whole new sciences in terms of toxicology and environmental toxicology have been developed over the last 50 years. There's been a lot of activity there. And people who apply pesticides have to go through a lot of training, and more so if they're going to apply things from the restricted use list. Finally, one of the issues that people raise is that, but I can't get information about this. There's a lot of information to allow people to put things in perspective. And a lot of information is recorded as records that are usable by the people who regulate the people who apply the pesticides. So it's not like this is an untracked thing. And with that, I'll go to the next speaker and we can do questions later.
Thank you, Dr. Savage. Our next speaker is Mr. Jerry Ornelas. Kauai native, farmer, retired as a research technician from the University of Hawaii's College of Tropical Agriculture and Human Resources in 2011. Mr. Ornelas started working on the family dairy farm in the 1960s, then continued on with vegetable and orchard crop farming. Today he grows tropical fruits. Let me see, wait one moment. Tropical fruit trees in Kapa'a homesteads. It's on the next page. He is president of the Kauai County Farm Bureau and chair of the Kauai County Agricultural Advisory Committee. Jerry is the Kauai representative to the State Board of Agriculture, and he presently serves as previously served as the vice president of the Hawaii Farm Bureau Federation. Jerry?
Thank you, Laurie. I'm not a renowned agricultural scientist. Obviously, I'm a farmer from Kapa'a Homesteads. We are running late, and farmers like to turn in early. So I'm going to be yielding my time for our dialogue. Yeah, but one quick word. When we do dialogue versus discussion, yeah, dialogue means that we have to suspend some of our assumptions. Right? We all have mental models and we all have assumptions. But today, let's try and suspend those. Let's not get really defensive about our positions, because I can tell you right now, neither side is going to go away anytime soon. We're going to have to learn to live together. This is a small place, guys. I know this because as a small farmer, as small farmers, we survived during the era of pineapple. We survived during the era of sugar. We actually had more agricultural activity going on in those days than we have today. We had a cannery full on right up the road that worked 24/7 this time of year when they were harvesting pineapple. Right across the street, right here, Maimona Hospital, they had not only their own farm that produced all of their vegetables, right? They also had their own dairy. Yeah, so I've seen them come and go, guys. I've seen all 5 dairies in this side of the island disappear. Yeah, I've seen the pineapple go. I've seen the sugar go. I don't want to see us lose another industry. Okay, we've worked very hard trying to develop our economy here, to diversify our economy. Yeah, we lost Wapakai in Kilauea. This is a good example. Okay, we lost Kapa'a in Kilauea. Totally irrigated, beautiful setup. What's being done with the land today? Yeah. Did we suddenly rush in and are now farming all of the land? I know son, you're up there, and they've got a good gardening program. I know, but most of that land, what's happening? I know they got a beautiful restaurant, but I mean, not to pick on that area, but really, if we lose these guys, we're not going to all of a sudden tomorrow have agriculture spreading across the Mana'a Plain. That's not going to happen. We have some serious issues that we need to work out regarding increasing our demand for our products. Anyway, I'm running over, so I'm going to stop now and get up here, and I can give you the local perspective. Let me put it that way. So if you got questions, please. All right.
Thank you, Jerry. I would like to call up the speakers to the table up here, and if Thelma, if you could get some cups of water for our speakers, that would be wonderful as they're coming up. I also want to start by, for those of you who came late, reviewing the rules before we start. So participate actively, listen. Thank you.
And then if you can remember, when you're posing your question, if you have a particular panelist, if you would indicate, that would be great.
Thank you. Yes. Wants to go first? Joanne, Councilwoman Yukimura. First question, concise.
How can a politician be concise? My question is for Dr. Folga. You said that it's good to be able to move genes faster than in the traditional breeding method. But you have a gene that's going into a system of genes. How do you understand all the interactions that happen? I mean, it seems like you're going into a lot of unknown territory.
Well, it seems like we are, but actually we're moving things into very well understood territory in many cases. Genomes have been sequenced, which means we understand the parts list of all plants. Of certain plants, we understand all the genes that are there and the organization they're in. We understand the proteome, which means all of the proteins that are produced by plants we can look at and understand and evaluate, kind of account for. So when we're adding another gene, it's nowadays very simple to figure out where it integrated into the genome, if it's producing any spurious products. All the details are actually pretty easy to come by these days. For a few $1,000s in a week's time, all this information comes from cores that do the work. A really nice example of this is the gene for apple scab, a rather devastating disease in apples. Took 50 years to integrate that gene by traditional breeding from a wild apple into commercial apple. 50 years, millions and millions of dollars, and many careers. They were able to do it with a transgenic approach in 5 years. So it confers this very valuable trait in a short time just by moving that single gene. And I'd be happy to follow up with this in more detail if you like.
Okay, Marta, and then the lady in green. How's that?
Hello, my question is for Kevin. You take your nematode-proof flavorless strawberries and compare them to the initial genetically modified crops, which were created to use minimal pesticides. Compare those to today. Why do we have bugs that, and if your environment is so controlled in the laboratory, why do we have super weeds and super bugs that are now requiring more pesticides? They've evolved to overcome this controlled environment.
No, you hit the nail on the head. Pests, whether they're weeds or bugs, have been continually evolving with humans' efforts to control them ever since the beginning of time. And it's something that always will be there. A bacterium doubles its generation every hour, or every 20 minutes, every hour. An apple tree once every 10 years, or 5 to 10 years. So you can see the opportunities for one to gain a foothold over the other genetically. That's why we need something like the ability to move single genes very rapidly, because to meet these challenges, we have to have that agility. Things like super weeds, for instance, super bugs, those are buzzwords that are used that I don't particularly think are precise, because a super weed is resistant to one more chemical. It's not so super, it just means you need an alternative strategy. And this is what happens next. Yeah, it's an escalating arms race, but that's...
So how do you have so much control that you talk about? I mean, I would think nature is really evolving.
Well, it's not really evolving in the laboratories, it evolves out in the field where you have millions and millions of
maybe
plants.
we can
Okay, yeah, you're right. I'm
yeah,
sorry.
Yeah, thanks. Hold that thought and talk to him later. Thank you.
Okay.
No, we didn't even hear it, right?
Okay, my question goes to Steve, and is about, since he knows much about California, how wide are the buffer zones in California to residential areas and schools and waterways?
Buffer zones depend a great deal on what you're working with. So, for instance, if you're talking about a soil fumigant, which is something you use in strawberries because we don't have access to Dr. Folta's nematode-resistant strawberries, that has a very substantial one. I'm not sure what it is. I forget the exact number, but it's something like a mile. I mean, it's a big amount. And then for other things, it all depends on the particular properties of the chemical. And that's appropriate. That's the way it should be done. Because to say, well, we're going to have the same buffers for every single kind of chemical, which I think is what it says in Bill 2491, that's going to be overkill for some things and underkill for others. It really ought to be customized to the chemical And that, of course, takes the resources for somebody to be looking at that, and that's why we have something like the EPA and the state level EPA.
Okay, my question goes to that same topic about the buffer zones. 6 out of 9 agricultural counties that hold all the agricultural in the Central Valley, California, have a quarter-mile buffer zone around schools and sensitive areas. And I would like one of the panel to answer why the HCIA and this group is fighting a buffer zone for Waimea.
I can't speak for the ACIA, but what I can tell you is if you're talking about southern San Joaquin, you're talking about cotton, and you're talking about aerially applied pesticides. That's what that would be about. Defoliants in general that are going to go onto the cotton. And so, yes, if you're doing aerial application, you need a lot bigger buffer zone. But the rest should go to Kirby.
Yeah, sure. Sorry, I'll find my distance, I hope. The concerns we have with the 500-foot buffer zone, part of Bill 2491 is, for one, by the time you include all the roadways and waterways, it cuts out a large portion of our land, large portion of the farmable land. And, you know, what would we do on that? The other part is, what is the scientific basis of that? Where did the 500-foot come from? You know, where's the studies that show that will provide safety, any more safety than 100-foot or 50-foot or what's currently on the labels? Right now, for a pesticide to be registered, that's one of the requirements it has to go through with the EPA before it can even become a product. They study its drift characteristics, and they establish things like minimal wind speeds that you can apply it in, and if there is concern, distances from other surrounding things, and that's what we follow. That's what's been studied heavily already. So we just have problems as guys who trust science where that number came from, because that is a lot of land. It really is, that would be taken out of production.
We have a question right here.
Thank you all for a very informative discussion. I think my question is either for Dr. Savage or for Dr. Folter, or perhaps for both, because we have one who talked about pesticides and one who talked about GMOs. But what we didn't hear enough about, I think, is GMOs designed to be resistant against pesticides. This is, as I believe, over 90% of the GMO products that are out there are engineered to be resistant to, for example, Roundup. We have the Roundup Ready corn, soy, sugar beets, canola, cotton, alfalfa. These are the core crops that are being, you know, massive monocrops over the U.S. core cotton belt. And I think that this is a serious problem because it's caused a very large increase in the use of Roundup over the last 10 years because of these crops. And this is, and now we're getting more and more of these Roundup resistant weeds, which is causing the farmers to use other much more toxic chemicals like atrazine 2,4-D. And now I suspect what the industry is trying to do is to develop GMO resistance to these other chemicals on top of the Roundup. And I think that's a really scary thought. So I'm predicting we're going to have a lot, and of course Monsanto has already asked for and been granted substantial increases in the residue, the Roundup residue allowed on various crops. As a direct consequence, I think, of this process, which I think is not, I mean, it's an arms race that we're going to lose, in my opinion. So I'd like.
One thing I can tell you is that before there was Roundup Ready soybeans or Roundup Ready cotton or any of those things, there were herbicides being used on all those crops. Okay. Yes, well, yes, they were directly on the plant.
If they're on the plant dies. That's the point. Now you can just spray it on the plant. They used to do it before they planted the crop.
No, sorry.
Actually, if I could just take a quick break, if we can allow each other to speak without interrupting, and then for Dr. Savage, once you're finished, ma'am, if you have maybe another comment, we'll get back to you. Can we agree on?
Because what was being used before is what was called a selective herbicide. So it was something that you could spray on a soybean and not kill the soybean. Now, in some cases, soybean looked pretty bad for a few days, and that was not very attractive, but it was sprayed right over the soybeans. It's just that now you have something that you can spray right on the soybeans, and the soybean does just fine. So it isn't that there wasn't herbicide use before, and now you're saying, well, because of Roundup Ready, we're using more toxic pesticides. They're not actually more toxic pesticides. 2,4-D, for instance, is probably, it's actually just about as non-toxic as glyphosate. 5,000 milligrams per kilogram, you know, in terms of the statistics, that's the number. Now, I see smiling, and you're saying, well, this is Agent Orange. This is not Agent Orange, okay? Agent Orange was a combination of 2 herbicides, but the actual problem in Agent Orange was a dioxin contaminant. That's what caused the horrific problems, but that is not what is in 2,4-D. 2,4-D is something that is allowed to be sprayed on your home lawn. Go to your garden center. You can find lots of products with 2,4-D in it, and you have been able to for 60 years. So managing resistant weeds is a challenge, but the main way that you do it is by having more than one option. And that's always been a good idea. I would say it's fair to say that a lot of farmers overused Roundup Ready soy in particular because it was so convenient. There were a lot of people saying you should mix it up with some of the other older herbicides. But again, this is an old problem. As long as we've been doing things, pests have been getting around whatever it was we were doing.
Yeah. And I'll just comment too. I do agree that you know, more is not better. And when you talk about something like glyphosate resistance, there are weeds that are naturally resistant to glyphosate. They either move glyphosate into specific compartments of the cell where they inhibit the enzyme that's inhibited. They're turned over by the cell. So some plants just naturally aren't susceptible to glyphosate. And so when you use glyphosate and kill everything else, these move right in. And they populate the fields. There's tremendous problems with Johnson grass, all kinds of other problems all over the Midwest, caused because of overuse. And that's understandable. And the stack trait will help to mitigate that. Ultimately, there are other technologies in the pipeline where there are treatments that will treat the plant first, or treat the weeds before there's glyphosate applied. And this does, at least from the preliminary work, it looks like it'll be a substantial way to decrease the use.
You have a question from the back of the room here?
Okay, thank you. Basically, I want to clarify the question that came a couple of thank you. You were talking about, depending on the product, you can need as much as a mile or sometimes more. It varies, the amount of the buffer time, the buffer area, right? So you were saying the buffer area can vary depending on the product that you're going to use. And then Kirby said, oh yeah, that's why the 500 buffer area doesn't work. I mean, please clarify for me. So then you need minimum 500 feet, and therefore you maybe need more than 500 feet? Because does it make any sense?
It's because we're talking about the extremes. So if 2491 went in place, you would have 500 feet for everything. So if you were an organic grower spraying BT, which is something we've used safely for 60 years, it's actually in the list because it says general use. It says general use. Whereas something like methyl bromide, which is a fumigant, and the way those things work is they're extremely toxic, but then they're gone pretty soon. But during that time that they're there, you know, you have to be extremely careful. Now, the mile is probably way more than is actually needed, but it's, you know, sort of being as safe as possible. But also, that's something that is used on an extremely small area today. In fact, we're just about to the point where it's not going to be able to use at all, not because of that, but because of its effects on ozone layer. So it all depends on what you're working with. That's why one size doesn't fit all. It just doesn't make any sense.
We have a gentleman over here, another gentleman there, and then I think we had another person here, and then Ned and Don. Okay.
Last night I asked you guys about why we should trust you in Waimea, and I didn't feel like my answer was adequately addressed. So I'm going to ask this a little bit differently. When it comes to this bill, the right to know what you guys are spraying before you spray it, in my opinion, is a common courtesy when you're spraying as much as you are as close to our homes. And I was wondering what you guys are so afraid of in allowing us to know what you guys are spraying. And so that's what I really need to know from you about this disclosure, about this bill. I know you have issues with some of the other stuff and, enforcement and that stuff. But really, if I was at my house and I knew the conditions were unfavorable and you guys were spraying at a particular time, I could responsibly be able to safeguard my family. And I think that is my right as a taxpayer to be able to do that. Could you please address that in the disclosure?
Sure. Yeah, and I'm glad you came back tonight because I don't think I answered your question adequately either last night. And to follow up, I thought about that more. And to follow up a little more, I think, if you want to, the question is, how can you trust us, what we say, what we're doing? We say we're following all the rules, but what I can say is you're at a good start right now, just coming here and being willing to listen and learn. It's great to get dialogue with people in the seed industry, and better yet, what's really effective has come out and tour one of our sites. And I think that's a really good way because we can show you hands-on what we're doing.
I'm sorry, if I can ask you, if we need a clarification of his question, if I can go to the individual? Yeah.
I'll get to it.
If you don't. But sir, I'm sorry, sir. We have to set ground rules that everybody will abide by. If I can please ask you to do that.
It's okay. I got it.
Okay, but then let me clarify, if I can. Wait, hold on. Please, everybody. I know there's some emotions that are high in here. I really do appreciate that. But if we can maintain some order here, and just for clarification, so you can get some satisfaction, and the original gentleman. Were we about to get to that point?
Yep,
Were you working your way towards it, Kirby?
Yeah, so
Okay.
the biggest
we'll work our
problem
way
we have with the disclosure part of 2491 is that it requires you to report what you're going to spray 72 hours in advance, which is 3 days, which just makes it really impractical as a pesticide applicator because we scout for the bugs or the pests and then we make our application. And we do it, you need to do it as quick as you can. Within good weather conditions, okay? And if you have to know that somehow 3 days in advance, it makes it really difficult to know what you're going to spray. It would almost even make you have to spray more because you might have to, just to protect your crop, go ahead and put it out there just to make sure that those bugs don't come in. It's just from an IPM, integrated pest management standpoint, it makes absolutely no sense. Another confusion it would create is, so we already have to have signs on the field for federal WPS standards to mark them when we spray, so that our workers know it's called re-entry interval. So when they know when it's safe to go back into the field, those signs have to be posted already. So now we'd have another field up 3 days before the spraying, 3 days after the spraying, 6 days out of the week. One chunk of land might have 4 or 5 different fields in it that are treated separately. What you'll end up with is driving by the west side, you'll just see signs up all the time. And I just wonder what you will learn, what the gain is from that. You know.
Planned sprays, right? I mean, it's not all just improvising. There is planned sprays, correct?
No, not necessarily.
Repeat the question.
Okay.
Well, you do have planned sprays. It's not just all improvisation on your spraying. I understand that, there is times. So, I mean, is there some way that we can work with you on some of this and then maybe other things that are not, you could be putting it down and then marking it down on a website that said, these were, the last minute. At least we have some sort of record going forward. And it just, as you say, it presents this dialogue that continues. We have less unknowns, less assumptions, and it continues. We get better at it as we go along, but...
Yeah, there is, I mean, we have spray programs in general. We know we have to put a herbicide out there early to protect the crops from weeds early on. There's some insects that attack the plants early on too, little thrips. And then there's not much going on until the seed's almost ripe, and then this earworm comes in and starts attacking it. So, but still, you do scout and you don't deploy those crop protection measures until you actually see the bug, and that 3-day just really works against trying to be good stewards with your pesticide program. So that's a really difficult part of it.
Could I offer a thought and maybe a good solution here? From University of Florida, we've managed to cut our fungicide applications on strawberries by 60% by analyzing the weather patterns that are conducive to fungal problems. And what happens is when those weather stations see those predictions coming together in terms of humidity and temperature, they flag every farmer has a text message that goes off on their phone that says, spray within the next 24 hours. Something like this could also be used in this context where perhaps a text message goes out to those who would sign up to receive it and would give you an idea that within the next 24 hours, the conditions are conducive and there's a highly likely chance of something being applied. That's technically very feasible these days, and I can't speak for the industry, but maybe a good way to find a compromise and make everybody happy with this particular situation.
Before we go on to Lori's gentleman, maybe if we can just reiterate the contact information for all the speakers are available. And I know, Kirby, I think you mentioned you welcome folks to contact you guys in case they were interested in tours of the facility. So the speakers really do encourage you guys to be able to contact them directly and continue following up on your questions until you get satisfaction. So please take advantage of that. Thank you.
Line 92.
Thank you for your information tonight. A lot to take in. Maybe this question is for all of you. Can you tell me, since January of this year, has anybody been affected by any of your spraying out there or anywhere on Kauai, physically, where they had to be treated in any way?
I'm not aware of anybody else in the seed industry out there aware of anything. No.
We have 71-year-old women that work out in the fields for us, and they're healthy as horses, and they'll be happy to attest to that tomorrow, I'm sure.
We have 3 other questions.
Oh. I would just like to speak. Oh, I'm sorry. I would just like to speak a little bit about the bill because the bill actually does not affect organic farmers. It is addressed specifically to those on the island who annually use in excess of 5 pounds or 15 gallons of restricted use pesticides in any amount. And then it goes on to list the buffer zones for those that use that amount. It doesn't say anything about general use. It says any pesticides for those folks, general use or otherwise, that must be their buffer zone, but it doesn't say for everyone else. Only those that have the 5 pounds or 15 gallons annually, not everyone.
But it would be an extremely tiny farm to be under 5 pounds or 15 gallons.
I beg your pardon?
It would be an extremely tiny farm to use in a year less than 5 pounds or 15 gallons. Organic farmers use pesticides.
Not restricted use pesticides.
But you just said general use.
No, I'm just saying that the bill says, okay, if I need to ask a question, we'll ask a question, but I'm trying to read the bill, which is right here, which does clearly say that for the buffer zones, the disclosure every bit of the bill is aimed specifically towards the commercial agricultural entities that annually purchase or use in excess of 5 pounds or 15 gallons of restricted use pesticides, any amount of any experimental pesticides or both, during any calendar year to restrict the application of all pesticides, restricted, general use, or experimental in the following areas. You cannot use any pesticide, those people that use the restricted, within 500 feet of any school, hospital, residential area, or public roadway. And you may not use it near waterway. And the thing that you yourself said, Stephen, I believe your name's Stephen, is that most of these are really, really dangerous around water. You yourself said that. I wrote down.
I don't think I used the word really, really dangerous, but I said there are things you need to take proper care with.
Okay, but you said that.
Yeah, I mean, that is the reason that they're on the list. I didn't say really, really dangerous.
Okay, but you said they have the potential for contamination of the water by many of those specific pesticides that are on that list.
Right.
There is a high potential, and I've read all of those MSDS labels, and that is the thing that jumps out at me the most is the water.
Yeah.
Okay, thank you.
Luisa, thank you for that clarification. Just to give you an example of regulatory measures, I attended a workshop last week on something called NPDES, National Pollution Discharge Elimination System. Now, just that title should give you an idea of where we're going with this thing, yeah? They now require special permits to apply any pesticide near water, right? This is a federal regulation that came down. The State Board of Health just developed the rules. They were tardy in developing the rules, supposed to have been developed earlier. We're going to have layers and layers of regulation. Yeah, and that's my concern. The other concern I have as a small farmer is that at some point somebody is going to sue and say, wait a minute, if those big guys are forbidden from spraying these products, how come that guy can spray it? Right? He is applying the exact same rate per acre as the large farmers are applying. I don't think that's going to hold up. I mean, in court, I don't think I'm going to win. Right? If somebody comes and says, you know what, you're spraying the same thing as the big guys. So that's basically our concern, is that eventually it'll trickle down to us.
And I just want to clarify something because I think there's a little confusion about what 2491 says. And Dr. Savage, the qualifier for the buffer for pesticides that are affected by the 500 buffer is the 5 pounds or 15 gallons use of restricted use pesticides, which pretty much means the 4 seed companies on Kauai and then 1 other coffee company. And that's what triggers the buffer zone for RUPs and general use in that area. Does that clear everything up? Okay. We know that. Yeah.
That is correct, but remember one thing. When this legislation was formed, they took a snapshot of what's happening exactly right now today. Yeah? In 1980, we had over 600 acres of papaya growing on Kauai, right in your neck of the woods in Moloa. In fact, on land that NID farms and Sun formerly farmed, right, we had 600 acres of papaya, right? They would definitely fall within those parameters of 5 pounds or 15 gallons because they use a lot of fungicides. Yeah. Now, nobody wants to see increased pesticide use, but we've taken a small snapshot right now and say, gee, 99% of all the restricted use stuff used by the seed and coffee industry, when technically, if you look at the historical background, that wasn't always the case.
Okay, in the European Union, they banned atrazine and paraquat and stuff like that. Now, why is there persistent use of these chemicals here on Kauai, especially when I've taken samples out of the Kapa'a ditch, and there's definitely more than 3 parts per billion in there. I don't know how much, just from my test strips, but why, if you say you're turned a new leaf of using more modern kind of things, why are you still using atrazine and paraquat in large quantities on this island?
Oh, couldn't hear the question.
Yeah.
Can you guys repeat
I
it? You
think
heard
the
it?
question was why are you still using atrazine? He says it's not being used in Europe and and paraquat. Okay, there's a couple things there. First of all, one of the reasons that these things are not used in Europe is it's a lot wetter. Okay, and so keeping things out of water. No, seriously, keeping things out of water is a much bigger challenge in Europe. Also, the reason why are you using old things? Turns out it's harder to find new herbicide leads than it has been for other things. We've found a lot of new, very interesting and really, pretty benign insecticides and fungicides in the last 20 years. The rate at which people are being able to find new herbicides is slow. So some of the things that have been around for a really long time are still used. Now, they're only the ones that have been through 10 or 15 regulatory reviews over the years. And atrazine, the use rates of atrazine have been changed dramatically from what they were in the past. The restrictions on how far from a wellhead, there's all sorts of things that have been done. And in terms of how much atrazine is there, every year the USDA takes water samples all over the country and analyzes them, and they look, and they have an actionable level of what is too much, and this is not what they're seeing in those samples. It's basically, and we're talking here on millions of acres of use in the Midwest and lots of rivers. So again, I think if it was easy to find a really nice alternative to atrazine, it would be great. But frankly, actually, if people had used a little more atrazine as a preventive method instead of just relying on glyphosate, we might not have some of the glyphosate-resistant weeds that we have. It's good to have a bunch of different things being used.
I'll sit down. Have a seat with you. Couple of quick comments and then a couple of questions. First of all, this would mainly be for Kevin. When we look at pests in general, anytime you have monocultures of the mind and grow monoculture crops, you are sending a blinking red light out for pests to attack your crops. In the little island of Yap, the average farmer can name 350 species of plants on their farm. They have no problem with disease. I have 53 different crops on my, almost 50 on my farm. My sheep take care of my weeds. The weeds haven't become resistant to my sheep yet. To Kevin, your question about losing this 500-foot buffer strip and all this acres of land, I'll tell you what you do with it. Give it to sustainable organic farmers to grow food for us, because none of you are growing food for us. And it's required. It's in our state constitution, Article 11, Section 7. It says the state and the county must strive to be self-sufficient. It's very, very clear in there. That means produce our own food. Thank you. You got it?
Yeah. Can I just take a quick break before your question, Don? It's 8 o'clock. I want to respect people's time because we started late, and I just went up to the panel and asked, could we extend this to 8:30? Would that be okay in the interest of trying to get some more questions in? And so if it's okay with everybody else, if you need to leave, thank you for coming. If you have to head out, thank you again. But we're going to get to Don's question, and we have 1, 2, 3. Oh. Yeah, and I apologize, as I explained, we're going to try to hit the first timers first and then get to the second timers. So we had 1, 2, 3. We did have 4 here. Show of hands, 5.
Savage, you mentioned, and I quote, you've got to be careful that you cannot let these pesticides into streams. In
February 7th, 2012, there was a minor rain event, not a major one like we had in March of 2011 where we had 31.5 inches of rain in 10 days. But on that rain event on February 7th, and I sent this video, YouTube video, to all our council members this morning or this afternoon, it shows a viscous river of mud running off of Pioneers Field across Kaumuali'i Highway in Kauai and into the ocean. Now, again, don't let them get into the water. Well, when you're a farm company from Indiana, the heartland, and you're 2,000 miles from the ocean, and all of a sudden you're tilling fields down to 15 feet from the vegetated buffers.
Don, you're gonna kill me. I need a question from you. I'm so sorry, just so I can get the other 8 people in. Can we get your question, Don?
Yes, Kevin, will you volunteer to let sustainable organic farmers grow in those buffer strips to grow food for us so we can increase our food self-sufficiency?
You mean Kirby?
I'm sorry, Kirby.
It's fine with me.
Yeah, thanks, Kevin. I'm not sure, the way I read the bill, if you qualify as one of the companies that goes over the limit on RUPs. The way I read it, you cannot spray any pesticides in that 500-foot buffer. So if you can't spray any pesticides in that buffer strip, but you can next to it, if the pesticides are going to drift across that 500 foot and potentially harm whatever is on the other side of that 500-foot line, why would it be okay to put sustainable or organic agriculture there?
It wouldn't be appropriate to use sustainable farming. That's correct.
So you just answered the question for me, I think, that you cannot do it? Or what? I can tell you, 2007 video, just come look at the farms now, you're going to see a lot more grass, conservation practices, keeping the soil in sight, less of that erosion. And that is something, the conservation practices is just growing grass around the edge of the field instead of tilling or spraying herbicides, mowing the ditches. It's actually cheaper for us and easier in the long run because it takes a lot less fuel to run a mower over it than to pull the big heavy plow or disc through it. So again, it's just come out and see the farms and see the things that we're doing. I think there's some misconceptions from what you know seen in the past.
So you put in vegetated buffer strips when you want farming?
We have vegetated buffer strips in.
500 feet wide?
No, they're not 500 foot.
Okay, we have a question over here.
My question is for Stephen Savage. It was just about the pesticide concentration figures that you were talking about. This is about the concentration of the pesticides that you're talking about. So if I understand, it was 23,000 pounds and you had 12,000 acres of corn. Now, Kirby just said that there's 13,000 acres total, so that must be more than one growing season?
Of crops. And then also, yes, and when I did my math, I figured 2 seasons worth because I was comparing it to per season in the Midwest. There's actually probably more than 2 seasons, but I just used 2.
No, not exactly. And then the really, really tiny number that you had up there, that was in terms of pounds per square foot. But the other figures that you were talking about were in terms of pounds per acre.
Right.
So if we convert that to pounds per square foot, what do we have?
We divide so I had 1.9 pounds per acre, right, per year. That was the per year number that I did that with. And you divide that by 43,560 square feet in an acre. And that's how you get that really little number.
May I ask you, just because we have maybe about 6 or 7 questions more, can I ask me with Stephen?
Huge misconception. I could have finished it already.
Okay. Finish this up.
Okay. So if that's 2 growing, essentially you got 4 pounds per acre?
No, the 1.9 was just dividing by the 12,000.
Right, but we don't have 12,000 acres at one time in production of the 13,000. I go out there every day, I know it's not that intense.
Okay, but it's in a year, okay, but there's 12,000 that's farmed at some time in the year. And we have that many pounds at some time on those acres in the year, so that's the 1.9.
Well, okay. I'm
can
going
I
to
clarify?
apologize right here because we're
Yeah.
getting to sound like it's a math question and
Yeah,
also
I'll-
availability of land question.
I explained why I have to go through this. This quote said that unfortunately in reality, we don't know how to think about very large or small numbers. So I'm trying to go through it because he thinks that our minds are small and we don't understand this.
No, it's just, I mean, what do you do with 20,000 of anything? Yeah. I mean, if I...
Oh, wait, hold on.
If I
if you don't mind
composted-
allowing Steve to answer.
If I composted 10 acres, applied compost to 10 acres of organic, I could easily use 50 tons of compost. I mean, when you start getting into acres, you can get to pretty big numbers pretty fast. That's all. And I don't mean anybody has a small mind. I'm just saying, when somebody says 22,000 pounds to me, it's like, I don't have anything that I can relate to 22,000 pounds. I don't know anything that I can think of and visualize that weighs that.
Okay, if you can get to your point and we'll finish this one up if that's okay. Thank you.
So essentially you're using 3 to 4 times as much pesticides as you would per acre on the mainland in a similar type situation because you have more growing seasons here, is the point.
No, actually, if you divide it by how many growing seasons, you're actually less. Yes, look, we'll do the math. I'll show you.
If I can clarify one thing too, ma'am, we don't plant the same square footage, we don't plant the same part of that land more than once a year. So we have a lot of small fields that we put in a big field, just like this room. You see all the rooms at the field, but we might have, the picnic table there might be one field in January. And then when that crop's done, we'll plant this spot next to it a couple months later. So eventually we get a lot of fields all over that land, so that area, that section of land is getting pesticides applied to it during one growing season of the year only. It varies. Like during the winter cycle is probably the biggest. There's probably anywhere around a third to half of the land out on the west side planted during the winter cycle. Then the spring cycle is a little smaller, and then the summer cycle, we fallow everything on the west side and plant everything across the fallow line, which is basically split right through the middle of the island. So you don't see any corn on the west side during that one cycle of the year, but you see other crops over there. It's just corn that we fallow. So we rotate different crops around on different pieces of the land throughout the year, but there's pretty much just one crop per year on that land.
Well, okay, so for your satisfaction, is there any way that you would be willing to meet with Steve or Kirby individually? Yeah. Would you guys be willing to sit down with her at some point? Because she should get, some satisfaction for her questions, and depending on how you're going to dissect it, hopefully there's some way that she can get her answers to her questions. Okay.
Oh, okay. Hi, my name's William Ash, and I have a question for the board in general. I know that in the stacking of chemicals or drugs in a person's body, like in the stacking of chemicals and drugs that are sprayed upon the land, you're going to have different things going to influence other things and cause them to degrade at the same rate because they're with them. Roundup in its advertisement says that it lasts for approximately 4 months, can keep down weeds. When you put all these chemicals together and you go out there and you apply it and it tills and it blows and all that red dirt goes flying all the way down and coats all the little houses all over the west side, do you think this has something to do, those chemicals and that dirt, in those 200 people putting a lawsuit against, what is it, Pioneer? Who's got the lawsuit? Pioneer? Do you think that has anything to do with the wind vector and the dust and the chemicals that don't break down? Anybody?
First of all, I understand dust, and I can see why somebody would be upset about dust. chemicals do break down in the soil, so it's not like they don't. And but dust is a problem. But actually one of the best ways to reduce dust in combination with, you know, the grass and things he's talking about is to do your weed control without tillage.
So you do think that possibly the particles of those chemicals reside with the dust and are airborne and go directly across?
At incredibly low levels. The amount that would be in each little bit of dust. So on a square foot, remember that calculation, and we're something, you know, some amount that is like sort of infinitesimally small. And so in a grain of dust, it's, you know, 10,000 times smaller than that. So I think you would, if you took the dust, you'd be really hard pressed to even find it there. It would be interesting to look.
Is there anybody looking?
I wouldn't know.
That particular lawsuit is not a personal injury lawsuit. That lawsuit is a nuisance lawsuit. So there's not necessarily health issues associated with that particular lawsuit because it is a nuisance lawsuit. I'm sorry? I'm assuming it could, absolutely. If the evidence was there, I see no reason why it wouldn't. I think that was the original intent, but for lack of evidence, I think they went with a nuisance lawsuit rather than a personal injury lawsuit.
Okay, I'm sorry, guys. Because we're limiting, because I've limited other folks to one question, if you don't mind. But again, I encourage you to speak to.
It's for Kevin, and I'm interested in public health impacts and consumption of GE food. And you mentioned that there hasn't been a report of a public health incident related to consumption. I'm wondering how we would know or track that since they're not traced or labeled in our food supply. How would you ever do that study to know if certain public health trends are related to consumption of GE foods? And what would you recommend that we do in order to be able to better track those sorts of things?
Yeah, it's a good question. And I think one of the major issues in looking at this is the way we deal with any type of epidemic. I'm sorry, I can't. I'm looking at you through the camera. I don't mean to be, rude there. The way that we track any kind of public health problem, whether it's bacterial, viral, whatever, is when you start to see any incidents of illness or any type of dystrophy, the Centers for Disease Control and other agencies spring into action to identify what is the causal agent. And we're looking strictly at an epidemiological level here too, acute levels. These things come together very quickly when you start to see the stars lining up between different groups or different people or even animals sharing a common vector for some sort of a disease or disorder. This is really the major way in which, and I know it maybe sounds like an unsatisfactory answer, but the testing has been done up front from in silico, in computer tests and models in the test, understanding the mechanisms by which these things work, by understanding the mechanisms by which they integrate with physiological systems. These things are very well known and very described. It allows scientists to test very specific hypotheses that have been tested and show that there's not a problem. So I'm personally a big fan of surveillance. I'm somebody who, surveillance in a disease sense, speaking from a pathophysiological sense, to be able to watch for disease and disease incidents, it's important, and it's something that is watched for all diseases and all disorders, not just related to GM.
2491, and it is to put another layer of regulations needing the county. And we all know that there are federal and state regulations now in effect. Do you know of any state in the country that has a county that has passed a bill similar to 2491?
Not that I'm aware. I'm not a. Do we have a government affairs somebody in here from somebody? I haven't heard of such a thing. That wouldn't be my experience. Oh, sorry. I'm asking if there's somebody from some company's government affairs, because I mean, that's not something I've ever heard of, but that's also not something I would track. I kind of stay out of politics.
Has passed a bill similar to 2491.
Not similar to 2491. Now, there are a couple of counties in New York, Suffolk County and something else, I forget what it's called, that have particularly sandy soils. And so they have some of their own restrictions on certain things. And so you'll look on the labels and it'll say, you know, da-da-da, but not for use in Suffolk County. You know.
We have specific restrictions in Hillsborough County in Florida, but those come from the EPA and from USDA in response to looking at specific pesticides and their use in certain horticultural crops. But those come from a federal level.
Okay, here we who this is for, but I think it's for Kirby. I think it's for Kirby, my question, but I'm not sure. To put it in context, more than 200 years ago, 250 years ago, this island was self-sustainable and self-sufficient, and there was probably more people living here than there are now, if my information is correct. Jerry brought up a problem that I'm very concerned with, which is we seem to be moving in an opposite direction of self-sustainability and self-sufficiency because of our overdependence on technology and our approach, somehow, our approach to feeding ourselves. The dairies have disappeared. A lot of the food that used to be grown here is not being grown here to feed us here. We are growing things to ship out of our island elsewhere in the world and buying it back in products. And that's how we're feeding ourselves. According to the statistics that I'm familiar with, 80 to 90% of the food right now on the island is imported. My question to Kirby is, the companies have been here now for at least 15 years, the GMO companies. What have your companies done? You know, feeding the world is a motto that I keep reading a lot, feeding the world. What have you done to help us feed Kauai, to feed ourselves? In those 15 years, please.
Thanks for asking that. And just to clarify, it's been over 40 years since the companies have been here. And we support all agriculture on Kauai. I personally support the goal for sustainable food production on Kauai, and I see our industry as enablers for that. These, you know, one thing we've done on a lot of these big chunks of land, like Kapa'a, for instance, is kind of resurrected the irrigation system, if you would, after the plantation closed in 2001. For a few years, nobody was maintaining all that. All the fields became overgrown with Kauai, the ditches were clogged, and then boom, in 2005 we had huge rains and everything flooded up out there. And 2006, and we've been working hard to reclaim that. We've been cleaning out those ditches, regrubbing our fields, and getting everything back in shape. Maintaining that irrigation system takes an operating budget of $1.4 million a year. Is that right, Steve? Is that $1 million? Okay. Well, $1 million a year just to keep the water flowing. So I see us as enablers to help with local food production. We're not against that at all. As far as what have we done to feed Kauai, our products is seed that goes back to farmers in the mainland who are growing grain. Most of that grain goes to feed cattle or hogs or chickens. If you like to eat meat, that's part of our product. There's other uses of corn. It goes into hundreds of other products that come back. No, it's not as unprocessed, you know, fruits and vegetables like what we could get locally. Another thing I just want to add in onto that too is with my opening comments was that, you know, we're only using roughly 20% of the tillable ag land on Kauai. There's plenty of land out there. If somebody wants to go farm and grow more food, we're not stopping them. We're not in the way of that. We would support that. So I'll end with that.
your observation is correct. You know, these islands were self-sufficient, and interestingly enough, they did it without any outside inputs. But there's a reason that they're able to do that. Today, 2% of our population feeds the other 98%, right? So they had probably in the order of 80% of the people engaged in food production. Okay. So here we are, and in Hawaii, I can tell you it's probably somewhat less than 2% of the people actually engaged in farming. And if we emptied out our towns and sent everybody off to my farm, maybe we could get more production here, but otherwise, we're going to have to be using these tools, you know, unless we put a lot more people on the land.
Maybe you can make tourists do it.
Yeah, make them work.
Okay, we're